So in the last session, just we covered about collections sort method. So what is collections? Collections is an utility class to define several utility methods for collection objects. Correct or not? For collection. In the last session we cover how to sort elements of list. Now we have to talk about how to search elements of list. Keep subheading searching elements of list. Searching elements of list. Okay, sir, I want to search a particular object present in the array list or not, or present in the linked list or not. I have to search. Okay, make sure you people should aware internally the search method use which algorithm? Binary search algorithm. Are you getting? Internally the search algorithm uses what? Binary search algorithm, right? Okay, just observe. So the method name itself, do you know? Binary search algorithm only. Binary search method only. Sir, in this list, can you please search for this object? Can you please search for this target element? Sir, in this list, can you please search whether this object is there or not? I have to search. But have you remembered some very important conclusion? Here see, if you want to use a binary search method, we have binary search algorithm is there. Binary search algorithm, compulsory the list should be sorted. Correct or not? Okay, this is first sort and then apply binary search algorithm. This is the usual binary search algorithm rule. If you want to apply binary search algorithm, compulsory the list should be what? Sorted, right? Okay, anyway, that rule is applicable here only. So here it's a public method. Sir, it's a public method. It is a static method. The return type of this method, sir, can you please check whether this element is available or not? Can you tell what is the return type of this method? The return type of this method. Can you please search whether this object is available or not? What is the return type of this method? Okay, most of the people are going to fill boolean. Yes, true or false. Available, not available, like no. The return type of this method is int. Int is the index. Int. What the meaning of this int? Okay, let me explain with a small example. Here, just observe this one. I'm going to take a small example. Here, see. Sir, I have array list is there. Now, can you tell which elements are there in my array list? Can you please cross check from the screen? Sorry. What is the first one? Z. Next one what? A. Next M. What the next one? K. Next one small a is there. This is my array list. Assume this is my array list. But if you want to apply search method, compulsory list should be sorted. Then I call collections dot sort method. Now if I call collections dot sort method, after sorting, can you tell the order? A. Next K, M, Z, and then small a. Okay, this is my list, right? Now what is the index? 0, 1, 2, 3, 4. Index is nothing but like, sir, I want to search for binary search of L. Sir, in this L, can you please search for this Z? L comma Z. Can you tell what the answer we are going to get now? Sir, Z is available at which index? Third index. That's why here the output by default we are going to get is 3. So clear indication. Successful search returns index. Sir, where this one is available? Successful search returns what? Index, right? Okay, this is first rule. Suppose I want to search for, sir, binary search of L comma J. Binary search of L comma J. Take a bit very special care. Is J is available or not? J is not available. If it is not available, unsuccessful search. Unsuccessful search returns insertion point, not -1. Oi, insertion point. Unsuccessful search returns what? Insertion point. Then immediately you ask, sir, what is insertion point? Simple. Insertion point is a place where you can take this J. Of course, it doesn't mean you have to add. If you want to add, where you can place a J? J we can place in which location? After A in this location. Then K will move to the next. Here we have to place. So insertion point is the place where you can insert this target element. Sir, here you can place. What is the position of this one? Is nothing. What is the position of this one? 1. Are you getting? But if I return 1, you people may feel, sir, successful search. It is available in the 1th location. Like that's why it is not. Insertion point is not 1. Insertion point is, if you want to place the element in this location, what is the insertion point? -1. If you want to place in this location, -2. If you want to place here, -3, -4, -5. If you want to place after A, of course you are not going to place. If you want to place after A, is nothing but -6. Because I am searching for small b. Sir, where we can place small b? After A will come. After A, then -6. Are you getting? This thing is by default considered insertion point. Are you getting right? Insertion point. Okay, like, sir, here, can you please tell unsuccessful search J, where you can place a J? In which location? In this location. What is the insertion point? -2, right? I hope you people give it. Sir, take a bit special care. Binary search method. Successful search returns index. Unsuccessful search returns insertion point. Insertion point is the location where you can place the target element in the sorted list. Is it clear for all of you? But now take a bit special care. Okay, sir, here you are telling J we have to place after J, but assume it is not my list, it is this list. Are you getting? It is this list. This list is not sorted. Can you tell in this where you can place a J? Hayo, you can't tell. Are you getting? If the list is not sorted, yes, you can't tell that J should come after A or before. Isn't a list should be sorted, then only you can tell that J should be placed after A or L should be placed after K. Something like, if you this is possible because it is sorted. If it is not sorted, it is not sorted like this, then how you can tell where you can place a J, where you can place B? You can't possible. That's why before calling binary search method, compulsory the list should be sorted, right? Is it clear for all of you? Okay, this say, sir, I didn't sort. Sir, I didn't sort, but still I am calling binary search method. We will get unexpected results. We won't get any compile time or runtime errors, but simple we will get what? Unexpected results. Is it clear for all of you? Right? So first point. If so internally binary search algorithm uses, binary search method uses binary search algorithm. Successful search returns index, unsuccessful search returns insertion point. Insertion point is the location where you can place the target element. Okay, this next before calling binary search method, compulsory list should be sorted, otherwise we will get what? Unexpected results, unpredictable results. We will get unpredictable results, but we won't get any compile time error or runtime error, right? Next here, see, observe this one. Sir, if the list is sorted according to default natural sorting order, then we have to use this method, sir. If the list is sorted according to default natural sorting order, we have to use this method. If the list is sorted according to comparator, then we have to use public static int, binary search of, can you please check list L. In this list, for which target element you are searching? Object target, comma, this list is sorted according to this comparator. Even at the time of search also you have to pass the same comparator. According to this comparator, like if the list is sorted according to customized sorting, then we have to use this method. If the list is sorted according to default natural sorting order, then we have to use this method. Are you getting? So collections class contain how many binary search methods? 2 binary search method. One binary search method is if the list is sorted according to default natural sorting order. Another binary search method is if the list is sorted according to customized sorting order. Any explanation is required about this one? Okay, at this point. Yeah. Collections class defines the following. collections class defines the following binary search methods. The following binary search methods binary search methods. Okay, take first one, public static int. First method, public static int binary search of, public static int binary search of list L comma object target. Public static int binary search of list L comma object target list L comma object target. Okay, now here the theory, public static int binary search of list L comma object target. Under the head, here this one, if the list is sorted then wait, if the list is sorted according to default natural sorting order, if the list is sorted according to default natural sorting order, then we have to use this method. Okay, better to take second method also. Public static int binary search of, public static int binary search of list L comma object target, list L comma object target comma comparator C, list L object target comma comparator C, comparator C. Better to highlight within the box. Okay, we have to use this method. We have to use this method. If the list is sorted, according to customized sorting order, if the list is sorted according to customized sorting order, okay, are you getting the point, right? Okay, this is next. Keep subheading conclusions. There are several theoretical conclusions we covered. Conclusions, first one, sir, here legend, the above search methods will use which algorithm internally? Binary search algorithm, because binary search algorithm is standard searching algorithm, right? Okay, add first one, the above search methods internally will use, binary search algorithm. The above search methods internally will use binary search algorithm. Binary search algorithm. Next, successful search returns. Index. Successful search returns index. Next, unsuccessful search returns. Next point, unsuccessful search returns. Unsuccessful search returns. What? Unsuccessful search returns insertion point. Unsuccessful search returns insertion point. Unsuccessful search returns insertion point. Okay, next point, insertion point is the location. Insertion point is the location. Insertion point is the location. Insertion point is the location where insertion point is the location where we can place target element. Where we can place a target element. where we can place a target element in the sorted list, where we can place target element in sorted list, in sorted list, in sorted list. Next, have you remembered one point we covered? Before calling binary search method, compulsory list should be sorted, otherwise we will get what? Unpredictable results, unpredictable results. Okay, this is add. Before calling binary search method, before calling binary search method, before calling binary search method, compulsory list should be sorted, compulsory list should be sorted, compulsory list should be sorted, otherwise we will get unpredictable results, otherwise we will get unpredictable results, otherwise we will get unpredictable results, unpredictable results. Are you getting the point, right? Okay, this is next. Now last point a bit important, take special care. Sir, if the list is sorted according to comparator, sir, customized sorting, how you can implement customized sorting? By using comparator. If the list is sorted according to comparator, then at the time of search also we should pass the same comparator object. Sir, if I am not passing comparator object, but the list is sorted according to comparator, then we will get unpredictable results. Are you getting right? If the list is sorted according to comparator, at the time of binary search method also, compulsory we have to provide the same comparator object. If you are not providing same comparator object, then we will get unpredictable results. Clear, right? Okay, add. If the list is sorted, if the list is sorted according to comparator, if the list is sorted according to comparator, then at the time of search operation also, then at the time of search operation also, then at the time of search operation also, at the time of search operation also, we have to pass same comparator object. At the time of search operation also, we have to pass the same comparator object. We have to pass the same comparator object. Otherwise we will get unpredictable results. Otherwise we will get unpredictable results. Okay, that's all. How many points came, Anna? 6. So make sure you should have clear clarity about these conclusions, right? Now let me go for 2 examples I will explain. First example, how to use if the list is sorted according to default natural sorting. If the list is sorted according to comparator, how we can? Okay, simple. Just observe this one first. Here let me go for a simple example. Here see, here both. So observe this example right first. Sir, here legend this one. Here I am taking array list L is equal to new array list. Array list L is equal to new array list. L dot add of Z A M K A SOP of L. Sir, if I print SOP of L, can you tell what is the answer now? Z comma A comma M comma K comma okay A. Correct or not? Okay, this is because insertion order is preserved. But now I am taking collections dot sort of L. Sir, can you please sort list elements according to default natural sorting order? Can you tell what is the answer we are going to get? What is the answer? A comma K comma AK comma M comma Z comma A small a, right? Okay, are you getting? This is. Now I have to search for Z, I am searching for Z, I am searching for J. Okay, now observe this one. Sir, can you please tell which elements we added to the list? which elements we added to the list? First Z, original list. Analogy, original list. Z. Next one what? K. Next Z, A, M, K, and then what? Small a. Okay, this is my original list. Now this list is sorted according to default natural sorting order. If I sort according to default natural sorting order, can you tell what the answer we got? First A, and then what? K, and then M, Z, and then A. Oh, list is sorted according to natural sorting order. Okay, now observe, if the list is sorted according to default natural sorting order, now you can decide what is the index, what is the insertion point. What is the index? 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. What is the insertion point? -1, -2, -3, -4, -5, and then -6. Okay, like insertion point and index is there. Now I have to search for can you spell out what we have to do? Collections dot binary search of collections dot binary search of in this L. Can you please search for what? Z. Sir, is it successful search or unsuccessful search? Successful, because Z is already there. Then what is the answer we are going to get? 3 itself is the answer. Successful search returns index. Next, collections dot binary search of collections dot binary search of L comma J. I am taking L comma J. Sir, can you tell is J is available or not? Not there. Unsuccessful search. Unsuccessful search returns what? Insertion point. Insertion point is the location where you can take target element J. Sir, in this sorted list, where you can take J? Where you can take J in this location? What is the insertion point of this location? -2. That's why the answer by default we are going to get -2. Any explanation is required about this terminology? Okay. So successful search, unsuccessful search is nothing but like. Let me execute this code. Okay. Make sure here see. Same example. Collections search demo. Here just observe. Same example here. Let me compile and run this code. Java C collections search demo.java. Next Java collections search demo, right? What is the output by default we are going to get? First time before sorting Z A M K A, after sorting A K M Z A. Successful search 3, unsuccessful search is nothing but what? -2. Any explanation is required? Is nothing but like this. Sir, I want to make a small change here. Let me comment this collections dot sort. Sir, I don't want to perform sorting, but still I am calling search method. If I am not performing sorting, but still I am calling search method, now my list should be this one only, right? My list should be this one only, right? If it is the case, at least successful search Z is available in which location? 0th location, 0th index. So at least for successful search, can I get a proper result or not? You can cross check. If the list is not sorted, but still we are calling binary search method, what will happen? You know, unpredictable results we are going to get. Whether we are going to get or not, just observe. So here see, just I am commenting collections dot sort of L. Sir, I am not performing sort operation, but still I am calling binary search method. Now observe this one. What is the outputs by default we are going to get here is, have you observed? What is the answer? -5, -1. Is it predictable or unpredictable results? Unpredictable, because at least Z is there. Successful search, at least can you please provide proper value, but still we are getting what? -5. Are you getting the clear point, right? Okay. So compulsory before calling binary search method, the list should be sorted, right? Not required to keep any explanation. Okay. Take this example. So this is the example 1. Collections search demo. Take clearly. the list is sorted according to default natural sorting order, then how to use the search method? Take clearly, and beside every SOP take the corresponding output also. What is the collections dot binary search of L comma Z? What is the answer? First case, what is the answer? L comma Z 3. Second case -2. Collections dot binary search of L comma Z 3, binary search of L comma J -2. That's all completed, right? Completed, I hope. Three -2, end of the main method, and then end of the class. Okay, after taking, compulsory you have to take these diagrams, this part also just beside, so that what is index, what is the insertion point, you can aware. This one is index, this one is insertion point. Index, insertion point, like. Completed, right? Okay, completed, I hope. Next one, here see, I want to take one more example where my list is sorted according to comparator. Okay, second example I want to take, here see the program first. I want to take one more example. Here the list is sorted according to comparator. Okay, here see, array list L is equal to new array list. Now L dot add of 15, L dot add of 15, 0, 20, 10, 5. SOP of L. Sir, can you tell SOP of L? What is the answer? Oi, SOP of L. I didn't call sort. What is the answer? 15, 0, 20, 10, next 5. Okay, right. Now collections dot sort of L comma new my comparator. Boss, we are sorting based on customized sorting. So how this compare method is implemented? Return I2 dot compare to of I1. Are you getting I2 dot compare to of I1? What it means, Anna? Reverse of alphabetical order or reverse of default natural sorting, descending order, right? Can you tell what the answer now? 0, sorry, what is that one? 20, 15, next 10, next 5, next 0 we got. Are you able to understand? Now make sure you people should aware, right? Here 1 minute. 0, 10, new my comparator. Can you please search 10 element in this. Can you please search 13 in this? Can you please search 17 in this? Are you getting? So just observe. Sir, can you tell first which elements we added? Can you spell out first? 15. First before calling sort method. What is the answer? 15. 15. 0. 20. 10. What is that one? 5. Okay, this is before calling sort method, my list. Okay, after calling collections dot sort, can you tell what the answer now? 20, 20, 15, 10, 5, 0 like. Okay, this is the list L after calling sort method. But is it default natural sorting or customized sorting? Customized sorting, right? Now, what is the index? 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Okay. Can you tell what is our first method? Collections dot binary search of. Collections dot binary search of L comma. We have to search what? 10. L comma 10 comma new my comparator. L comma 10 comma new my comparator. Sir, if the list is sorted according to comparator, at the time of binary search also, compulsory we should pass the same comparator object. Now, L10, in this L10 is there or not? Yes. Then what the answer? 2. Successful search returns what? Index. Next, collections dot binary search of L comma. What the next one? 13. L comma 13 comma new my comparator. L comma 13 comma new my comparator. Can you tell what the answer? Sir, in this I want to search for 13. Where 13 is available? Where we have to place 13? In this location. In this after 15 13 will come in descending order. That's why what the answer? Minus 3. Okay, minus 3. Next, collections dot binary search of collections dot binary search of L comma what is that value? 17. L comma 17. Have you remembered in our conclusions, last conclusion? Can you please read once? Last conclusion? In the conclusions law, if the list is sorted according to comparator, at the time of search also we should pass the same comparator object. Otherwise we will get what? Unpredictable. Boss, list is sorted according to comparator, but at the time of search I am not passing comparator. That's why what will happen is nothing but unpredictable result. Are you getting? Unpredictable. I will show that unpredictable result also. Suppose if you are taking like this, collections dot binary search of L comma 17 comma L comma 17 comma new my comparator. L comma 17 comma new my comparator. Oh, I am passing comparator object also. Can you tell where we can take 17? Where we have to take 17? After 20. That's why what the answer? Minus 2. Minus 2. Predictable result, right? Minus 2 is the answer we will get. Are you getting? So this is what how we can perform binary search if the list is sorted according to comparator. Now let me execute this code. Here same example, same binary search of L comma 10 comma new my comparator. Can you tell successful search 2, unsuccessful search 13, minus 3, but 17 you are not passing comparator object, that's why unpredictable, right? Now observe this one. Here collections search demo 1.java. Okay, collections search demo 1. Yes, collections search demo 1. Have you observed? First time before sorting 15 0 20 10 5, but after sorting 20 15 10 5 0, I am searching for 10, successful search index 2. I am searching for 13 minus 3, correct? 13 minus 3 like. Okay, 13 is nothing but minus 3. But 17, what is the answer? Minus 6. But actually what is our expected answer? Minus 2. But I am getting minus 6 because you are not passing any comparator object. Suppose, let me pass comparator object. Let me pass comparator object also. Now L comma 17 comma new my comparator. I am passing. If I pass comparator, Either result is the predictable or unpredictable. Predictable. What the answer we will get? Minus 2. Can you please cross check? Is it correct or not? Is nothing but have you observed? Last one minus 2, right? Predictable result only we will get. Okay. So anyway, let me remove that part. Okay. Like take this example. This is second example 2 for search method. So take clearly. So before sorting, of course after sorting, collections dot binary search of L comma 10 comma new my comparator. 2 is the answer. Collections dot binary search of L comma 13 comma new my comparator. L comma 13 comma new my comparator minus 3. Collections dot binary search of L comma 17. The result will become unpredictable. Completed, I hope. Take clearly. After taking this program, now take this total thing. This total thing. 15, 0, 20, 10, 5, minus 1, minus 2, minus 3, like. Collections dot binary search of L, 10, new my comparator, L, 13, new my comparator, like. Collections dot binary search of L, 17. The result will become unpredictable. Completed, right? That's all. This is binary search method. Even in the erase class also we have to search, we have to use this method, but there all rules are same. That's why compulsory here you should have clear clarity. Then there I will use only one word. All rules of erase class binary search method exactly same as collections class binary search method. That's all. I won't explain these things once again because these rules are same. Completed, right? Okay. Now, so here just observe one small possibility of asking the bit for the exam. Here see, there is one possibility from this binary search method. Just have a look once. Okay. Sir, I have one list is there. This is the list. Sir, this list contain 3 elements are there. How many elements are there? For the list of 3 elements. List of 3 elements. Can you tell what is the index, Anna? What are possible indexes? 0, 1, 2. What is the insertion point? -1, -2, -3, -4 also. Because I want to search for small a. Where we have to place small a? After Z. After Z means -4. You are not going to place anyway. If you want to place, what is the place? -4. Okay. Now my target is for the list of 3 elements. Successful search result. Successful search result range. What is the successful search result range? If the result is success, what is the range of results? 0 to 2. Correct. Successful search result range either 0 or 1 or 2. Next, unsuccessful search result range. Unsuccessful search result range. What is the unsuccessful search result range? -1 to -4. No, -4 to -1. Because -4 is small when compared with -1. -4 to -1. Are you getting? Next, sir, total result range. Total result, whether it is the successful or unsuccessful anyway, total result range. Can you tell what is the total result range? -4 to 2. -4 to 2. -4 to -1. 0 to 2 is nothing but -4 to 2 is nothing but like we have. Are you getting? This is for the list of 3 elements. Why don't you summarize? For list of n elements. For list of n elements, successful search result range. Successful search result range. Can you tell what the answer? Successful search result range 0 to n minus 1. Correct or not? Successful search 0 to n minus 1. 0 to 3 minus 1 is the 2. 0 to 2. Next, unsuccessful search result range. Unsuccessful search result range. What is the unsuccessful search result range? Minus of n plus 1 to minus 1. Are you getting? Minus of n plus 1 to minus 1 is nothing but like we have. Next, total result range. Total result range. Sir, whether it is the successful or unsuccessful, what the result range? Minus of n plus 1 to n plus 1 to n minus 1. Minus of n plus 1 to n minus 1 may be a chance to ask for the list of n elements. In the case of binary search method, what is the successful search result range? Unsuccessful search result range may be a chance to ask mathematical formulas like this. Okay, add. Take a note. For the list of n elements, for the list of n elements, in the in the case of binary search method, for the list of n elements in the case of binary search method, in the case of binary search method, in the case of binary search method, okay, first one, successful search result range, 0 to n minus 1. Successful search result range 0 to n minus 1. Next, unsuccessful search result range. Minus of n plus 1 to minus 1. Minus of n plus 1 to minus 1. N plus 1 to minus 1. Next, total result range. Minus of n plus 1 to n minus 1. Minus of n plus 1 to n minus 1. Minus of n plus 1 to n minus 1. I hope completed, right? Okay, this is for list of n elements. Example, like you can take this one. Now exact values for 3 elements. A, K, Z like. Successful search result range 0 to 2. Unsuccessful search result range minus 4 to minus 1. Total result range minus 4 to 2. Total result range minus 4 to 2 like. Minus 4 to 2. Minus 4 to 2. That's all. Completed, right? This is what you people should aware. Total result range. Okay. Successful search, unsuccessful search. Next, total result range is nothing but like. Now completed, right? Okay, that's all. This is to search elements of list. Next, third utility we have reversing. Keep subheading reversing elements of list. Reversing elements of list. Sir, I want to reverse the elements of list. What is the answer? What is the method we have? Simple, not required to keep much explanation. Public static void What is the method name? Ayo, what is the method name? Reversing. Reverse of list L. Regarding public static void, reverse of list L. Okay, simple. Suppose just observe this one. Listen. This example also. Here collections class contain. Okay, this reverse method. Okay, nothing. First add the theory, and then we will talk about example. Add collections class defines. Collections class defines. Collections class defines the following reverse method. Collections class defines the following reverse method. The following reverse method. The following reverse method to reverse. The following reverse method to reverse elements of list. To reverse elements of list. To reverse elements of list. Okay, take this method. Public static. Take public static void reverse of list L. Better to take within the box. And just observe. Let me go for a simple example. Here see. Okay. So here have you observed? L dot add of 15, 0, 20, 10, 5. SOP of L. Can you tell what the answer now? What the answer now? 15, 0, 15, 0, 20, next 10, 5. 10, 5 like we have. Sir, collections dot reverse of L. Sir, reversed. Elements are reversed. Now elements order. Can you tell what is the output we are going to get? 5, 10, next 20, next 0, comma 15, right? Are you able to understand, right? Okay, but here make sure here see. Sir, don't feel sir 15 is there or 5 is there. After calling reverse method, now the element will become like this. No, just only order will be reversed, but element won't be reversed. Make sure just only order, not elements reversal. Okay, order reversal this is. Okay, take this method, take this program. Collections dot reverse. Take this program. Only order of elements will be reversed, not element reversal. Completed, right? Ten, 0, 20, 10, 5 like 5, 10, 20, 0, 15 like. I hope is clear. So the output is okay. Completed terminology. This is about the reverse method. Clear, right? Next one. Here just observe. It is one area where most of the people are getting confusion. We have reverse method is there. Just now we covered with example also. And we have reverse order method is also there. We have reverse method is there. And we have reverse order method is also there. Reverse order method also. Reverse and reverse order method, both methods are there. Okay. Sir, what is the difference between reverse method and reverse order method? Simple. Can you tell what is the purpose of reverse method? To reverse elements of order of elements of list. Sir, I have list is there which contain 10 elements. Can you please reverse the order? Then we can go for reverse method. But what is the purpose of reverse order method? Make sure you should aware. Reverse order method to get a reversed comparator. Then immediately I ask, sir, what it means? Here see, sir, I am taking collections dot reverse order method. I have one reverse order method is there. This reverse order method can take comparator object. Reverse order method can take comparator object. Now here the return type of this method is comparator C1. Sir, what is the difference between argument comparator and the return type comparator? Assume if this comparator talks about ascending order, this comparator talks about ascending order, then the comparator what I am going to get because of this reverse order method, this one talks about what? Descending order. Are you getting the thing right? We can use reverse order method to get a reversed comparator. To get reversed comparator. Are you getting? So we have comparator for ascending order. Sir, I want comparator object for descending order. I have comparator for alphabetical order. I want comparator for reverse of alphabetical order. Then we should go for reverse order method. Clear for all of you, right? Reverse method is there, reverse order method is there. Don't get confused. Sometimes maybe a chance to ask, what is the difference between this? Reverse method to reverse order of elements of list. Reverse order method to get a reversed comparator, right? Okay, keep subheading. Reverse versus reverse order. 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 Completed, right? Add the theory. We can use a reverse method. We can use a reverse method. We can use a reverse method. We can use reverse method to reverse. We can use reverse method to reverse order of elements of list. We can use reverse method to reverse order of elements of list. Reverse method to reverse order of elements of list. Order of elements of list. Next para. Whereas we can use reverse order method. Whereas we can use reverse order method to get a reversed comparator. We can use reverse order method to get a reversed comparator. To get reversed comparator. To get reversed comparator. Okay, that's all. Are you able to get right? Okay, so make sure comparator add. Take this example. Comparator C1 is equal to collections dot reverse order of comparator C. Collections dot reverse order of comparator C. Comparator C. Like we have. So this is C1 meant for what? Descending order. This comparator meant for what? Ascending order. Meant for descending order, meant for ascending order. Make sure. So reverse method is there, reverse order method is there. Completed, I hope. So that's all. These are the three utilities what we have to discuss as a part of collections class. Sorting, searching, reversing, right? Okay, that's all.